Hey, it's Dr. Inductor again, and I'm going to talk some more about current. I talked about it in my first video, but this is just going to be more in depth, just like my last video on voltage. Okay, shall we get started? I started my last video with the definition of volt, so I'm going to start this with the definition of 1 amp, okay? 1 amp equals 1 coulomb passing through a point during 1 second. So really 1 amp equals 1 coulomb per second through any point, okay? Now, I said in my first video, current is just volume. It's the amount of electrons flowing through the wire at one time. So that's given to us in this equation. It makes perfect sense that 1 amp is 1 coulomb per second, because that's the amount of electrons and during a specific amount of time. So it's the flow rate. Alright? Now, the difference between voltage and current is that voltage is fixed, and current, it's floating, but only up to a certain threshold. Let me explain. Okay, so you have your battery. Let's say this one's 12 volts, okay, and it's capable of supporting 30 amps. You have a DC motor right here. DC is direct current, and let's say it draws 10 amps. Just forgive me, that's my left hand. Let's say it's drawing 10 amps, okay? Now, it's still receiving 12 volts. It's always receiving 12 volts, but it's drawing 10 amps. Now, if you switch that motor with, let's say, a 15 amp motor, that motor would still be getting 12 volts. It's always getting 12 volts, but this time it's drawing 15 amps. So, what you want to learn from this is that appliances, they draw their own amperage, but they all receive the same voltage, okay? So current is floating and voltage is fixed. That's why you can't measure current on a network of power. You have to just, with trial and error, see how much current it can support. You can't just take a multimeter and test current, okay? Now let's talk about the flow of current, okay? We say, or this is what actually happens. Do you remember that model I gave you on the atom? Yeah, the electrons are far away from the nucleus in a thing called an orbital. So they're actually easy, since they're so far away from the nucleus, they're not attached very firmly, and they can be ripped off easily. So electrons are the things that are flowing. It gives us electricity, okay? And they flow from negative to positive, okay? They make their journey this way. But since scientists are all optimists, I guess, we say that positive charge flows the opposite direction. We use that as conventional current flow. So any schematic diagram you ever see will, usually any schematic that you see will be using conventional current flow. So we'll say that it flows in this direction, and we denote that with an arrow. Okay? That's basically all you really need to know about current for right now, so let's move on.